Hey SolidSmack, in this video I'm really excited to bring you the product development story behind Core. Core is a handheld device which guides users through meditations. It's especially great for those of us who are super stressed out and don't really have any idea how to meditate, which is like most of the engineers I know. This thing uses a bunch of different sensory outputs to guide users. There's haptic feedback, there's lighting elements, and it couples with an app to provide audio guidance. Full disclosure, Core is a client of my optical engineering company, Starter, for the lighting elements on it. So my opinion of the product in general is going to be biased, but the engineering lessons that they've learned and shared with us here generously in this video are still really interesting. So stay tuned if you want to learn about things like using wood in mass-produced objects and measuring heart rate reliably without huge, bulky hospital equipment. Hi, I'm Erin McDermott. This is SolidSmack, and we are here at Core Wellness in San Francisco. This is Sarah Weber to tell us about what this thing is and what it does.
This is Core, a personalized meditation trainer. It's coming out in the new year, and Core really exists to help you build a meditation practice for daily life, to help gain more self-awareness into these crazy lives we have now, always hustling and leading to stress and burnout, and we really want to help people combat that.
Cool. How does this thing work?
So you hold Core in your hands, put your thumbs on top, and you'll feel it start to vibrate.
And the lights are turning on on yours?
Yep. So Core vibrates, and those vibrations can be DJ'd alongside the audio to help teach you breathing techniques or to serve different purposes. So we have guided meditations on an app that goes with Core, as well as we're opening a studio in San Francisco where you can take live in-person classes, and those classes will also be live streamed to users at home. The vibrations can be there as like a gentle reminder to bring your attention back to the present moment, or for all sorts of different breathing exercises that can help you become more energized or more calm, or all sorts of things.
Cool. So this is kind of like a tool for getting into meditation?
Yeah, a lot of the early people who have tried it have said Core really helps you drop right in.
Okay. Is there a steep learning curve then, normally without this?
Yeah, meditation can be really hard, and a lot of people try the apps, but they're also really hard to stick with. So Core also provides biofeedback at the end of your session, so you can learn the impact of the meditation on your body and kind of gain more self-awareness over time.
So biofeedback, that means it's measuring your biomarkers?
Yeah.
As you're using it?
So we measure your heart rate variability via ECG. So from that, we can derive different things, including your level of calm and focus at different points throughout the meditation.
Wow, that's wild. When can we buy one?
Early 2020.
Just look for it on your website?
Yep, hellocore.com.
Thank you. Thank you. So now we got Bash Ziadi here, what is your current title? Has it changed?
VP of Engineering.
Okay, great.
Yeah.
So you can tell us about all the technical stuff. Sounds like you had a lot of challenges turning this into reality.
Yeah.
Especially since, like, the EKG part in the hospital, that would be a huge
Yeah, like
machine.
a 12 electrode halter setup. Yeah, and it's really interesting how this has changed over time. But it was a really unique challenge to try and integrate like dry steel electrodes that are usable and easy and very consumer focused, that just always work no matter what. Make that just consistent. Instead of integrating like a more complicated like ambulatory EKG system, we giant battery backup medically certified system. We've managed to integrate a dry electrode, 2-electrode EKG system that's very consumer friendly, super easy to use, always works. One of those things where you just put your thumbs on, it instantly detects and instantly starts finding the signal and sorting it through. And when you're talking about like microvolts of signal, that's pretty hard to do with just like the sweat of your skin.
So are the normal ones not dry electrodes?
No, most normal like Halter systems in hospitals use wet gel electrodes that they stick to.
Oh.
And those are electrolytes. Those are things that create an ion channel, so that enable actual better readings. So it's a whole nother ball game when you're dealing with mega ohms of resistance on a dry electrode system.
So how many iterations? You probably can't tell me too much about the
I can tell you that the steel really matters.
Okay.
When we were prototyping, we got some steel CNC'd and we specified the type of steel, and we got it, and the signal just wasn't really coming out very well. It turned out to be a real headache. We spent a month hunting it down, and they just used whatever metal they had lying around the shop to set it. That was fun. So I've learned a lot about steel.
Wow.
And that's been challenging. Yeah, it's been fun, but now we've got it dialed in. It's working great.
Yeah, it works.
Yeah, it works.
Let's see, what else? So you also have real wood on these things. This isn't faux wood.
Right. For a consumer product, for something that you're going to leave out, something that will be an anchor, a reminder to come back to and use every day, we really wanted to speak to the users, be something that is of perceived quality, is something that people really care about. And we felt that just the weight, the warmth, the texture, the aesthetic, the uniqueness of the wood was really worth the engineering challenge. And it was an engineering challenge.
Why?
Well,
don't you just drill some holes in it and you slap it together?
Super straightforward, right? Yeah. Tolerances are real, and plastic's amazing. Plastic holds a tolerance down to like 0.01 millimeters on like bad tools, with like poor process control. Wood is a natural material, so it has all these pores, all these cells that expand and fill with water as humidity increases and as temperature changes. So you'll see like 1% variation on any dimension with wood. So that means that you can't really rely on a lot of these surfaces. So you have to do a bunch of engineering tricks to try and reduce the amount of wood in the stack up, or come up with ways to accommodate the variability of the wood. Because it also expands, not in all directions, it expands mostly orthogonal to the grain axis. And that's a whole nother challenge. It's another fabrication issue, yeah.
Are there models to see what the size would be after it expands? And did you use those, or did you just try to make it, like you said, put as little wood as possible in the place to get it together?
There's not a lot of design guides out there for how to work with wood, with natural materials of any kind, on consumer plastic-based interfaces. A lot of the times people try to reduce the amount of wood involved. They either try to like polymerize the cellulose, they try to just do
turn it into a plastic somehow?
Literally, yeah, that's what it means.
So you didn't have any guides to teach you how to just design this around wood?
So we did a lot of temperature, environmental chamber testing. We did a lot of analysis. We worked with a few different prototypes. We tried to identify consistent, high-quality wood vendors that can CNC wood and produce like the right aesthetic, the right quality level, the right price, and actually handle the scale of what we're building at a consumer scale. A lot of these are built to be like a few hundred or maybe 1,000 or two. We're talking tens of thousands of units a year, and so that's just a whole other ballgame.
Did the type of wood matter?
The type of wood does matter.
Besides just that it's pretty?
Well, that's probably one of the more important parts of the type of wood. But also that a denser wood tends to not expand and contract as much.
Makes sense.
Right. Turns out, the logic is right. And denser woods are heavier, they feel nicer in the hand. They also are a lot easier to machine in some ways. We've also found that different woods have different, their fibrous nature of their particular wood will make it a lot harder to machine and have a clean edge. What else?
Wow.
Yeah.
That's a lot of stuff.
Yeah, even, when you cut into a piece of wood, you don't know what the inside of the wood looks like until you open it up. So some of our initial batches actually had some weird internal markings that we were like, okay, well, we're going to have to steer away from that species of wood.
Oh, wow.
Yeah. So there's been a bunch of learnings in this process, and it's been quite a ride.
Who knew? It's just wood.
It's just wood. Yeah.
Can you tell us which type of wood that you went with?
We use a rosewood, yes.
Oh.
Yes. So it's got a nice red look to it. the grain structure is really beautiful. And each one's unique, you know, it's natural, it is grown. Yeah. We are also trying to be stewards of our planet, and we're working on ways to give back to the environment since it's giving us its materials. Oh, we're planting trees.
Oh. Okay, great.
Yeah.
So this thing vibrates.
Yes.
Are there any engineering challenges with that?
Surprisingly, so yeah. There are many ways to get haptic feedback to work and to work reliably and consistently.
This is a pretty big thing you need to...
Right. It's a few hundred grams, you know, it's a lot of mass to transfer energy through and to actually like vibrate in someone's hand while they're holding it. So tuning that and tuning it so that it doesn't numb your hands, like when you use a drill for too long, and tuning it so that it is pleasing, but you know, people of all levels of sensitivity can feel it, is very challenging. And then making sure that lasts the overall lifetime of the product, and making sure that it's reliable and has the same like turn-on threshold. Dealing with like the static versus kinetic force of friction, you know, it means that you have a different turn-on threshold and a turn-off threshold. Also, we found that we can find the right kind of motor such that the turn-on threshold is not actually perceivable by the user, which means its response time is a lot faster. And that's a major problem if you're dealing with electromechanical systems. The response times are in the hundreds of milliseconds. And when you are trying to track to an audio track, like the way we're doing it, where you want them to be synchronized as though it's like a tactile bass-like experience, you need it to respond really rapidly. So the time synchronization of those two systems is incredibly challenging too, to make sure they are spot on. That way the user really gets the value of the haptic system. There were a bunch of reliability issues, there were a bunch of consistency issues. Turns out, you know, haptic systems are still not really nailed down if you want to track frequency and amplitude. Most phones nowadays are on LRAs and they resonate actuators. Those are great. They're super reliable, but they resonate at about one frequency. We want to ramp. We want to roll in. We want high frequencies and low frequencies, high intensity, low intensity. So we had to go with a more traditional system, and that became a challenge because those wear over time.
So is the app actually telling it to ramp up, ramp down?
Yeah.
So,
Yeah, so our content system is actually providing both, you know, metadata as far as what the actual content is, you know, description, imagery, like who's it from, what kind of voice, what kind of category, but also audio, obviously, and it's a second track, which is the haptic track. That streams in concert with the audio, time synced to the device itself, in order to make sure that the haptics trigger at the right moment, to give the user the right impact and right feel.
Wow.
Yeah. Yeah. You know, you gotta bite off things that matter and get rid of everything else. It's very much a lean product focus, but that one mattered.
So after you've gone through this whole process, put all these very different things into hardware that you normally wouldn't have to think about for most hardware products, is there anything like that you would have told yourself when you started that you've learned now?
Oh man. That's a great question. I've developed this saying in a previous product, but it just keeps reinforcing over and over. Keep your friends close, but your vendors closer. Great vendors really make a big difference. Like people who will actually like go the mile for you, who do custom work, really push and promote you. They really make a big impact, especially when you're small and scrappy and you can't afford to you know, just buy all the machinery or make your own, or like, you know, have the leverage to actually make that happen. Yeah.
Awesome, that's great advice. Alright, we got a whole lineup here, Bash. What are you showing us?
Well, let's start from the most 3D printed one, which is the first 3D printed model of the like modern design direction after many, many, many iterations of foam models, 3D prints, different ID spins. Then we have the first build-up of that with an actual wood base here. It's still a mock-up of the actual plastics with crudely CNC'd electrodes. Then we have our alpha product, which we designed to really like get a rough sense of what's working and what isn't. This one actually still works. This
Cool.
was fully functional. This is actually the first step from the alpha product to the more modern design direction, notably the chamfer, the reveal there, instead of the plastic plate with the color pop. Then transitioning from this one to this one, we learned a lot in our alpha test, and one of those things we learned was both the curvature was not quite right, so we did a 23...
Why?
Hands are weird.
Period.
Biomorphology is a strange thing, and it's hard to fully capture. And so we learned that like there are hot spots right here where your thumbs touch. So when you press on, your thumbs are resting on this surface. That ends up hurting after 10 minutes, 20 minutes.
Yeah.
Another thing we learned is that like this level of bend is less ergonomic than just a like relaxed water hand, like as though you're floating in water.
Oh.
So we did a full usability study. We looked at a few hundred people and the way they hold the object.
Wow.
We mapped their finger placement. We changed the electrode design. You see how these start a little bit higher than this one?
Yeah.
Because most people keep their thumbs, the hot spots up here. The other thing we did is we increased the dot size, which is actually the electrode size, to create a higher likelihood of more average surface area contact for when a user is using this. It got to the point we were making like sub-millimeter modifications to the curvature
What?
and had diminishing returns, so we called that good. Then we have our EP3 unit. Now this is our beta device, and our production device is aesthetically identical. However, the internals have changed. We've made it more robust, easier to manufacture, and much generally like a better product to build and to sell. But this is the final design. Note the reveal to kind of hide and mask any wood swell, the larger contact area electrodes, the dead fronted lights, and the cammed interface in the back. So that is kind of the evolution of the product.
Wow. And that's barely touching on all the work that actually went into it. But it gives us a good idea.
It's a beautiful handhold onto a component of how difficult this was to iterate on. We're a very product-first company here, so we spent a lot of time focusing on developing the right kind of product for our users. We really wanted it to feel good, to be focused on the parts that matter, and to really be impactful for our users.
Awesome. Thank you.
Of course.
Core is expected to launch this month in January 2020, and you can find out more about how to purchase that at hellocore.com. As always, for more details and links, you can check out the full article on SolidSmack.com. And one more thing before you go, you should know if you're thinking about working at Core, they have an office dog. Yes! Thanks for watching.